Miss Hendricks and the other third grade students at North Wayne, and we are studying simple machines with Mr. Crosslin.
So, I've been invited here in the third grade at North Wayne to talk about a simple machine. And you guys know the thing about simple machines, right?
Yes.
A simple machine makes work
easier
over a longer distance. And so you've been studying, I can see in your room, you've been studying levers, you've been studying wheel and axle, wedges, and now we're going to study the inclined plane. And in just a little bit, you'll use this piece of cardboard, this block of wood, and you're going to experience how it is less effort depending on the inclined plane. And we're going to measure that with a spring scale. So that's something that you get to do right at the end of this discussion, okay? But how does an inclined plane work? Well, let's take a look. Here's a real simple one right here. The inclined plane, right? It says inclined plane right there on it. An inclined plane can make work easier. So if I wanted to, if I get this balance just right, too high and the weight goes up, too low and it goes down. But if I get it just right, we might be able to stop it right in place, right about there. So an inclined plane means I could just go straight up and down. That's a small distance, but a big force. Or I can go a long distance. So let's see. If I increase the angle, look what happens.
It goes up. It goes up. It goes up. Oh, Jesus. Oh, God.
And if I decrease the angle,
It goes down. Wait, it kind of goes down.
and somewhere in between,
It stops.
it stops. It's balanced. So that's a smaller version. I'm going to let you see this larger version right here. Let me pull this over here. Here's our larger version of it. And I have a bigger cart. Oh, how am I going to, what should I do so this won't go down?
Put it in the middle.
Increase the angle. Oh, there the angles increase and it stopped. If I continue to increase, what happens?
It goes down.
Let's see if that's true.
Because there's more weight on there.
The weight is the same, but the effort gets changed. Now here,
It goes up. It
So-
stops.
it stops because I got it balanced. But if I increase, it goes backwards. Gravity pulls it. If I decrease it,
It stops. It goes up.
nice. So, you might think, well, how does that work? Let's take a look at our next demonstration. All right, so an inclined plane. You know, we have a book about it right here. Inclined planes are everywhere. When you walk up the stairs, you're using an inclined plane. When you go up a ramp, it's an inclined plane. They've been around for 1,000 years. The pyramids were probably built, they probably used an inclined plane to put those big blocks up. And even the space shuttle, that a rocket that goes up in space, went up on an inclined plane to get to the launch pad. So inclined planes are used all the time. So we're going to try to show you how they're used. So I'm going to, well, I have this, this is the part Miss Hendricks may not like. I have here an egg, okay? And this egg, well, I hope it's going to be a happy egg. I hope this is a happy one. That means it won't break. A happy egg, okay? So
It's happy.
there's our happy egg, okay? Miss Hendricks, I'm afraid this one's going to be the
Sad. The mad.
this sad one because he's not going to use the inclined plane. Don't worry, he gets cracked up. Don't worry. All right, so here we go. So I'm going to make a plane, and what I want to do is drop an egg from this distance
Dear Lord.
straight onto here. What do you think is going to happen? Just from this height, do you think it'll crack? Well, let's put paper towel on it just in case. And I don't want to ruin my wood, so let's put a piece of plastic over it, okay?
It's gonna die.
There we go. All right, so still pretty hard. Let's see, is it still hard? Here we go. 3. Whoop. 3, 2. Oh, wait a minute, I don't have the heart to do this.
Let me do it.
Let's try what would happen if we used instead an inclined plane. So now the distance is the same. So we could either drop it
Or we could roll it.
or we could roll it. Now if we drop it,
It's gonna crack.
the distance is still the same, but it just has to be a short distance, but it's going to be a hard force. But if we use the inclined plane, let's see what's going to happen.
Smaller floor.
All right, here we go. Get ready. It's coming your way. Can you see all this?
Yes.
Here we go. Using an inclined plane, longer distance, less force. Don't touch it. I'm hoping the science works and we don't ruin the carpet. 3, 2, 1. Inclined plane. Hand it here. Oh, it's still happy. So we dropped it only from this distance to the floor. Let's try that again. Inclined plane, longer distance, less force. 3, 2, 1. Oh. Did you see what happened? It bounced. It bounced. It did crack a little bit, but not much. But enough. Miss Hendrick.
It's okay.
Look, Miss Hendrick's a bird. All right, let's see what happens. You know that I broke one of my own rules. When a science experiment works right, sometimes scientists like to repeat it to see if it works again. But you notice that one went and it flipped and banged. But this one, what do you think is going to happen first time? Let's find out. 2, 1. Yeah, that one. Okay. So, what did we learn? We learned that dropping from this height, it's better to use a ramp, longer distance, less force. Here, shorter distance, but more force.
Well, how? This remember this hooks up here. Like, yep.
So you can see that these students have been learning a lot about simple machines, the inclined plane, when you can reduce the effort by making a longer distance. Good job, guys.